This question from AP Physics B, 1986. These topics are now covered in AP Physics 2 and used to be covered in AP Physics 1. So in this question, they say that in the circuit shown above, X, Y, and Z represent 3 light bulbs, each rated at 60 watts at 120 volts. When they say 60 watts at 120 volts, that means if these light bulbs are connected to 120 volts directly, they would produce, or they would give away 60 joules per second, because watts is how much energy is given per second. So assume that the resistances of all bulbs are constant and do not depend on the current. And what is the resistance of each bulb? I do my calculations. I'm going to write the formulas. Also, when AP exam is graded, they look at every single thing that you write on AP exam. So writing all the formulas before you start deriving the formulas is important, and also deriving the formulas is important. You don't memorize the formulas when you solve the problems, or anywhere in physics you don't just memorize the formulas. So we have the Ohm's law is equal to I times R, and we have the power is equal to I times V. So these two formulas are given, but you also can substitute V and I in your power formula. So if you substitute I with V over R, you get the power is equal to, so instead of I will have V over R times V, which gives me V squared over R. And I can substitute V with I times R, so you will have I times V, but V is also equal to I times R. That will give you another formula, which is I squared R. So these are the formulas that you can derive from the other two formulas that are given usually on AP exam. So here they tell you that the power is 60 watts when it's connected to 100 volt battery. So I can use the top formula right here, because the power is given and the voltage is given. I can calculate what the resistance is going to be. So the resistance is going to be the voltage squared over the power, and that will give me 120 squared over 60. And that tells me that the resistance of each bulb would be equal to 240 ohm. So that is the answer for the first question, which is 240 ohm. And then for the next one, what is the equivalent resistance of the 3 light bulbs when arranged in the circuit shown? I'm going to redraw this circuit. I have this. For the circuits, I'm going to use the resistor. For the bulbs, I'm going to use resistor. Then I have the power supply. Then I have one resistor, which is another bulb. And then I have another one parallel to it. And I'm going to call this point and that point as A and B. So right here, when I look right here, I have point A, I have point B, and then I have the power supply, and bulb X, Y, and Z would be X, Y, and Z. So if I'm looking for the equivalent resistance, I see that these two are connected in parallel. When I calculate the total resistance of parallel connection, I can use this formula. It's 1 over R total is equal to 1 over R1 plus 1 over R2. And then if there were more than 2 parallel, you would add 1 over R3 and so on. My students usually see this formula, but we never use it the way it's given. What we do, we say 1 over, the result flip over. So if each one of them is 240 ohm, so and each of these ones is 240 ohm, I'm going to say 1 over, so 1 over 240, plus 1 over 240. The result is 2 over 240, but my result must be flip over. So the total resistance for those two, Y and Z, would be equal to 240 divided by 2, which is 120 ohm. Now I can redraw my circuit, and it will look like this. I have the battery, or the power source, 120 volts. Probably it's going to be the power source, not the battery. And then I have a resistor X, and then I have those two resistors replaced with one equivalent resistor. So this resistor is going to be, instead of the other two, I still have point A, and I still have point B, or the node. And then the equivalent resistor of this one is 120 ohm. But the resistance of the other one is still 240 ohm. Now these two are connected in series. They are sitting on the same line. And for series connection, all I have to add them. So the total resistance of these two is going to be 120 plus 240, which gives me 360. So for B, what is the equivalent resistance of the three light bulbs connected the way they are, is going to be 360 ohm. For the next question, they ask you, what is the total power dissipation of the combination when connected to 120 volt source as shown? So if you have the, let me redraw maybe the final resultant, so the circuit from here to here, and then we're going to have the resultant circuit as this, and then I have the final resistor that we calculated. So this is 120 volts, and this one is 360 ohm, the total resistance of the three resistors. And if I want to calculate the power from the power formula that we derived earlier, I can use V squared over R, and that will give me the power dissipated in the circuit the way it is. So I have V squared, which is 120 squared, divided by the total resistance, which is 360. So the power is going to be equal to 40 watts. So right here, that's going to be 40 watts. The power on the whole circuit, so produced by the whole circuits or given by whole circuits, is 40 watts. And then for the next question, they ask, what is the current in the bulb X? So the current in the bulb X is the same current as the one goes through the battery. It's right here when the current is going to be splitting between the two resistors. And it will be splitting evenly because their resistance is the same, 240 ohms. So if I want to calculate this current, I can use Ohm's law. So if I use Ohm's law, so I'm going to use this color for I is equal to V over R. So that will give me 120 divided by 360, which is 1/3. So I will have the current is equal to 1/3 amp. And what I did is the voltage divided by the resistance will give me the current. So right here I have the voltage is equal to I times R, and if I divide by resistance, I will get the current. So the current in the circuit is 0.33 amps. So right here, 0.33 amps. And then what is the potential difference across the bulb X? So if I know the current here is 0.33 amps, the potential difference is measured parallel to the bulb or the resistance that you're measuring. So you would plug in voltmeter, and you would want to know how much voltage out of 120 would drop in this light bulb. So to calculate the voltage, I have I times R, and my I is 1/3 or 0.33, and R is 240 ohm. So in this resistor, I have 240 ohm, and that gives me 80 volts. So out of 120 volts, I have 180 is dropped on the first resistor. The total amount of voltage I have is 120. So if the current is leaving the battery, I'm going to call amps my little aliens. So if 0.33 aliens are leaving the battery, by the time they get to this point, they will already spend 100 out of 180 volts, they will spend 80 volts on the first resistor. So they only have 40 volts to spend on the other two. So some of them will go this way, those aliens, and some of them will go this way, those aliens. So the aliens that went through resistor Y or the bulb Y, they have to spend the rest of the volts that they have and get back home. But what's left for them to spend is 40 volts. So between A and B, the potential difference between point A and B is going to be 40 volts. And it doesn't matter for those aliens whether they went through Z or Y, they have to spend 120 volts together. So if they spend 80 on the first resistor X, they will have to spend, no matter whether they go through X, through Y or Z, they have to spend another 40 volts. All we had to answer for this question for E, what is the potential difference across the bulb X? So that one we calculated 80 volts. And then what is the potential difference across bulb Z? As we said, you have 120 volts. 80 of it is spent on the first resistor, then the other two, no matter which one you go through, you spend another 40 volts. And that is all I have for this question from 1986. Usually I see a lot of students struggle with the circuit, so I'm gonna do a few more questions circuit related. So I hope you're learning, you're understanding better, and I hope that these videos help you to learn something that you didn't know. If you like them, go ahead and like or subscribe, and thank you for watching. I hope I see you in my future videos.